Hello and welcome to our overview on the 3D functionality in version 10 of the AccuMark software. This is the first lesson in a series detailing the workflow of using 3D models for AccuMark version 10. Click on the button at the bottom of your screen to begin the lesson. In this lesson, we will cover system requirements for using AccuMark version 10 3D, installation of AccuMark version 10 and the necessary accompanying software, and an overview of the basic workflow for rendering 3D garments. Click the button at the bottom of your screen to continue the lesson. In order to successfully and efficiently run AccuMark version 10 3D, your computer must meet the following requirements. The system must be configured with a solid-state drive or SSD. The processor should be an Intel i7 with at least 2.40 GHz of processing power. Your system should also have at least 16 GB of memory available to use and be running on a 64-bit operating system. AccuMark v10 will only run on Windows 7 or 8. And finally, your GPU or graphics processing unit should be NVIDIA Quadro K1000M or better. When preparing to run 3D for AccuMark version 10, there are a few extra steps to take in the process of installation. First, you must ensure that your version 10 software is set up for 3D. Once 3D is enabled, you can also download Blender from GERBER.net. Blender is a professional, free, and open source software that allows AccuMark to run the 3D simulation. You will not download Blender from their website, but through the software download portal on GERBER.net. The process begins in Model Editor, which is accessed from AccuMark Explorer. When opening a model in Model Editor from Explorer, it is crucial that you fill out all necessary items in order to move on to the next step. Click the button at the bottom of your screen to see a demonstration. The 3D visualization of garments begins with Model Editor. Information must first be provided about the model, pieces, and fabric. A new tab has been added to the Model Editor called 3D Garment Info. This page will include garment and fabric information as well as additional piece properties necessary to wrap the patterns around the 3D avatar. Once the first page of the model has been defined, the piece names, fabric types, and piece counts are copied to the 3D Garment page. There are three main areas on the 3D Garment Info page: garment, fabric, and piece information. Though some fields will be automatically filled based on default settings, you must ensure that all fields are completed correctly in order to move on to the next steps. The garments area includes fields which determine how the garment is placed, as well as which 3D avatar to use for the specific model. For example, garment category is a user-definable list of different categories of garments, while garment position will specify the location of the garment with regard to the 3D avatar. There are also optional areas for comments and a sketch of the garment. Fabric information, located at the top right area of the 3D tab, includes information about the type of fabric used in the model. After the first page of the model is defined, fabric types are copied to the fabric section, shown here. There are two options for specifying fabric information: fabric table and unique PLM material lookup. The fabric table will contain details about the fabric, including name, image name and location, and dimensions. Once this information is saved with the model and the model is opened in Pattern Design, the pieces can be displayed with the fabric texture fills in the PDS work area. Piece information is located at the bottom of the page. Piece names, fabric types, and piece counts are copied to this section once the first page of the model is defined. The piece information table also contains required information crucial to the assembly of the garment in 3D. The fields that are automatically copied from the first page are done so in a read-only state and will appear grayed out. If further edits are necessary, they will need to be completed and saved from the first page. The remaining sections must be defined in order to continue the 3D visualization process, and will be covered in more detail in the lesson on Model Editor for 3D. As input, piece position, piece orientation, body position, drape type, fabric layer position, and overlap type. Once all necessary information is filled out properly in the 3D Garment Info tab, be sure to save your progress before closing the window. Once saved, you can close the window and return to AccuMark Explorer, where you will then open the model in Pattern Design and continue the workflow for rendering a garment in 3D. Once the required steps have been taken in Model Editor, you will open the model in PDS and complete any necessary steps in the 2D workspace, including working with images and seam allowance. Click the button at the bottom of your screen to view a demonstration. In the previous demonstration, we discussed how a model editor can be used to apply fabric images with the fabric table. In order to view those images in Pattern Design, it is necessary to open a model with defined fabric types and 3D garment information. In addition to opening a model with defined fabric types, there are two preferences which must be enabled to view the fabric images within Pattern Design. From the Edit tab, select the Customize drop-down and then Preferences in the Workspace panel. Within the Color tab, ensure that texture is selected within the Fill Type box in the Fabric Fill section. Within the Display tab, select Filled Pieces in the Piece section. Press Save to enable fabric images to display permanently, and then OK to exit. Once the necessary adjustments have been made with preferences, you can use the View tab to toggle different views of the pattern pieces. Filled Pieces On/Off will show the image for any pieces in Filled Color Texture mode, and Fabric Trim Edge On/Off will show or hide all fabric, trim, and edge finish images for all pieces currently in the work area. With both of these switched on, you will be able to see any associated fabric images on all pieces currently displayed. You can use these functions to adjust how you view the pieces in the PDS work area. Another important aspect of the workflow in 3D virtualization is stitching relationships, which are defined on the sew lines of a pattern. This ensures the completed 3D rendering is based on the finished garment measurements. For this reason, it is important that the garment is saved in the sew state prior to opening the model in the 3D workspace. To work with seam allowances, first navigate to the Advanced tab. From there, click on Define in the Seam section to add or remove seam allowances to pieces. This function is necessary if no seam allowances are defined on the pieces of a pattern to be rendered in 3D. A positive value will add cut lines, while a negative will add sew lines. Additionally, entering a value of 0 will remove any seam allowance. You can also use the swap function to swap sew and cut lines if necessary. Remember, it is necessary to save pieces on the sew line as shown in order to successfully complete a 3D virtualization of your garment. Once all necessary adjustments with the pattern pieces have been made within the 2D pattern workspace, be sure to save the model before moving on to the next step, opening a 3D workspace. Click the button at the bottom of your screen to continue the lesson. When you have completed all edits in 2D, you can access the 3D tab and begin work on the 3D process, including rotation of pieces for proper placement and orientation, creating relationships, placing on the avatar, and creating a cloth simulation. After the model editor, 3D components are labeled and the pieces are complete with images and saved on the sew lines, it is time to complete the 3D preparation. The 3D tab provides functionality to open a 3D workspace. To do this, go to the 3D tab and select Open 3D in the Workspace panel. The 3D workspace will open automatically. The 3D work area will have an avatar icon in the tabbed header, and the workspace itself will default to a different color to distinguish itself from the 2D work area. Relationships identify how to virtually sew the garment. This step must be completed prior to starting the cloth simulation in order to successfully complete the 3D rendering. Create relationships is used to define the stitching relationships between pieces. When creating relationships, the sewing sequence is not relevant in pattern design. From the 3D tab, select Create in the Relationships panel. Select the first line to stitch, and then select the corresponding sew line. A dashed stitch line will appear to identify the seam. Once a relationship has been created, you can use the Manager function to make any edits, such as flip stitching or delete relationship. The process functions complete the final steps to render the 3D garment. Place on avatar is used to position the pieces relative to the avatar before displaying in 3D. The pieces should be placed so that the stitching lines do not pass through the avatar. Once you have selected Place on Avatar, the Place Pieces window will open. The pieces will be placed on the avatar using either the defined positions from the model editor or by creating arrangement points, which will be covered in detail in Lesson 4. If adjustments do need to be made, use the cursor to move the piece until it is in the correct location and then click to place. You can also change the avatar display using the camera icons such as front, back, top, bottom, and so on. When all necessary adjustments have been made, right-click on your mouse and select OK to continue. Finally, the cloth simulation function will display the model in 3D. This simulation utilizes the 3D garment information defined in the model editor, images added in pattern design, and sewing relationships to create the virtual garment. Once all setup is complete, select Cloth Simulation in the Process panel of the 3D tab. The simulation will begin automatically and launch Blender. Once the simulation is complete, you can also utilize the tools within Blender to perform functions such as take measurements, check fabric tension, fix collisions, or toggle the avatar on and off. Once again, please keep in mind that this is a basic overview of the functions of 3D rendering, and each of these steps of the process will be covered in more detail in the following lessons. We hope you have enjoyed this lesson. To continue learning about the workflow